So let me take an example and discuss that how these four models of synchronous and asynchronous computation can be used to solve a particular problem in four different ways. So let us suppose that we have an array of integers of size 10, as simple as that. Now if I ask you that you need to perform two tasks on this array. The first task is to compute the sum of all the numbers in this array, and the second task is to compute the multiplication of all the numbers in this array. So obviously you would going to write a synchronous single-threaded program in your normal day-to-day life. You simply launch a thread, you would first compute the sum of all the integers in this array, and then you will compute the multiplication of all the integers in this array. As simple as that. If I ask you to write a program that would perform these two tasks on this input array, obviously your first choice would be synchronous single-threaded program. But if I force you to write synchronous multi-threaded program to solve the same problem, then obviously it is possible. You would launch two threads. The first thread would compute the task T1, that is computing the sum of all the integers of the array, and the second thread will compute the multiplication of all the integers of the array. Alright? Obviously you are performing only read operation on the same data structure, therefore synchronous multi-threaded program to perform these two tasks in parallel is very much possible. Because read-read operation is a non-conflicting operations, you would not have to deploy any locking or thread synchronization mechanics. But now if I were to ask you to write an asynchronous single-threaded program to compute task 1 and task 2, then you would write a program and compute the sum and multiplication by executing each task in small cycles. You would first compute the sum of the first three integers in the array, and then your single-threaded program would switch to the task of multiplication, in which your program would compute the multiplication of first 5 integers in the array, and then your program can again switch to the same task of computing the sum of integers of the array, and this time it will compute the sum from index number 4 to index number 6, and again your program switches to the previous task of computing the multiplication of integers in the array, and this time it will compute the multiplication from index number 6 to 9, and finally it will compute the sum of the remaining integers in the array. So this is an asynchronous single-threaded program which would perform the same operations on an input array but in an asynchronous manner, dividing the work to be performed in small tasks and then executing those tasks. Here the task of computing the sum of all the integers of the array has been splitted up into 3 subtasks. Alright? So in asynchronous programming, if the task is big enough that it would take a considerable amount of time, then we choose to split this single task into subtasks. Here this is the subtask of computing the sum of integers of the array from index location 0 to 3. And this is another subtask. So a task of computing the sum of all integers of the array has been divided into 3 subtasks. And the same is true for multiplication as well. However, if the task is small enough that it would not take much time to compute, then in asynchronous single-threaded model, we compute that task in a single shot. There is no need to divide that task into subtasks. And finally, if I were to ask you to write an asynchronous single-threaded program to compute the task 1 and task 2 on the same input array, then you will launch 2 independent threads. The first thread will use asynchronous single-threaded model design to compute the sum of all the integers of the array, whereas the thread 2 will again use asynchronous single-threaded model design to compute the multiplication of all the integers of the array. But since these are 2 different threads which are executing, therefore we call it as asynchronous multi-threaded design. So I hope now it is clear to you how to differentiate between these 4 models of computation. But still, I believe things would not be crystal clear until or unless you write a program and see the things in action. So from the next section of this course, we will going to develop a library using which we can divide a work to be performed into individual tasks, and then we can execute those tasks in the same fashion as I have discussed in this slide.